Hello dear followers, my name is Emil Hacıyev and today we will try to solve this problem. As you can see, this is the function with two variables, and in this problem we should find the extrema of this function. As in the function of one variable, first of all we should find derivative of this function with respect to x and y in order to find critical point. Let's start. Fx is equal to 2x plus y minus 2. This is derivative of this function with respect to x. And then fy is equal to x minus y plus 1. Then we should equals it to 0. And we need to solve it. The best way to solve it is to sum up these two functions. 2x plus y minus 2 plus x minus y plus 1 is equal to 0. From here we can find x. Y is going. 3x minus 1 is equal to 0. X is equal to 1 over 3. And from here we can find y. 1 over 3 minus y plus 1 is equal to 0. Y is equal to 4 over 3. We find the critical point, which is 1 over 3, 4 over 3. Then to determine whether it's local maximum, minimum or saddle point, we use second derivative test, which has 4 cases. First, f has a local maximum at this point, at critical point AB, if double derivative of f with respect to x is less than 0, and this expression is greater than 0. Then, second case, if f has a local minimum at critical point, then it should the double derivative of function with respect to x is greater than 0, and this expression is also greater than 0. And f has a saddle point at critical point if this expression less than 0. The test is inconclusive if this expression is equal to 0. In this case, we should find the other way to determine the behavior of this function at this point. To solve this test, we should find fxx. So write fxx. We find it from here. We find the derivative of this with respect to x, which is equal to 2, and 2 is greater than 0. Then fyy, we find it from here. We find the derivative of it with respect to y, which is equal to minus 1, and then we find this expression fxx fyy minus fxy squared. And to find fxy, we should find the derivative of fy with respect to x, which is equal to 1, and this is equal to 2 multiplied by minus 1, minus 1 squared, which is equal to minus 3. And minus 3 is less than 0. And as you can see, in such case, we have that this expression is less than 0. It means that our critical point is saddle point. 1 over 3, 4 over 3 is saddle point of this function. As you can see, it's very easy to solve this kind of problems with second derivative test. And if you have any questions, feel free to write them in comments. Thanks for watching.